We're back.
Welcome back, everybody. Before we get started with our next talk, I've got another developer dilemma for you. The link is about to go into the YouTube chat, and the question is: should developers do design, or should designers do development? Feel free to jump in and cast your votes. Raita, why don't you tell us about what we've got next in store?
Well, our next speaker is Tetiana. Welcome, Tetiana. Let's see if we can get Tetiana in our studio. Hey, Tetiana, welcome.
Yeah, thanks.
Hi, hello. So Tetiana is a backend engineer at GitLab, where she works on security analysis. And in her spare time, she likes drawing or painting with any materials available. And in this talk, Tetiana will explore what we can create using Ruby and OpenGL. And we'll learn about the basics of OpenGL and eventually how we can build our own game engine. So, Tetiana, the mic is yours.
Thanks. So let me just today I wanted to talk about graphic programming, and I'm like in my day time job. I'm working on a security analyzing feature, so it's like literally something different field. And usually we are like tend to think about Ruby as a backend language for security, server client applications, but it can do much more. And as I like to draw and paint with like any material I get, so I was really interested in how I can do it using Ruby. And I would like to share my findings with you today. So I'll share my screen, and so I can show you what I got. So let's just start. Let's just skip to the scripts that I got. So like disclaimer, I'll be talking about super low level stuff today, and it's not like a production way to draw like production level animations or these modern video games that created right now, because it's operate on a level of vertices and like create like basically you need to create point one by one to create your scene, but actually it's super fun to understand how it works under the hood, and let's just find out. So what the code that I'm sharing right now, this is a script to create a scene on Ruby, and let me just start it. Like first picture for today, it works. So we have our application, and it's just like black screen, but we can, for example, resize it, and we can close it. So how it actually works? We need two things to it. The first one is we need Ruby-OpenGL gem, which is a binding for OpenGL API. And the second one is GLFWE library, which is like super simple controller, like handler for Windows and callbacks from the keyboard, mouses, and so on. What exactly is OpenGL API? OpenGL API, it's the way how we can communicate with graphic programming units. So it's basically get arrays of vertices of our points in our scene. It shaded assemble surfaces, triangles, or lines from these points. Then it rasterize it, apply some shaders, and then render it onto your screens. So we are right now talking about fourth level of OpenGL standard because it was changed over time, and I assume in the future it will be replaced with Vulkan API, because Vulkan API is like most modern one, and it uses more of the modern GPU's functions that we have right now. So like all of this is needed to render stuff on the screens, on your machines. And you can see that like if we're operating off the arrays of vertices, it's very low level. And OpenGL doesn't provide any functions to create any complex figures. And for now, maybe you understand that it's really hard to create something like spheres or circles or curves with this tool, because you like need to have the coordinates of all the points, and it took a lot of calculation powers. But as we're talking about OpenGL, like plain OpenGL, it could be possible to create quickly some really nice program, a nice scene. So let's just take a look on how such a graphic programming program looks like. So first of all, we have to create our window that I showed you before, and let me just make it a bit bigger. So when we create this GLFV window, we are setting a callback from the keyboard to this window, so we'll be listening on the all the events happening to the keyboard, mouses, gamepads. But like in our case, we just actually interested to know when escape key will be pressed, and when it's pressed, we can close the window. So like when we are set up in we set up our window, and then we can start actually entering our main loop of our application when everything will be drawn. So this loop will be entering on every change of the frame, and OpenGL operates in two buffers. So in the first one, like in a virtual buffer, we actually drawing our scenes that we have here, and when it's all done, it will swap to another buffer, which will be shown on the screen, and it will be like changing like all the time. So we when we enter in the loop, when we render in our scene, we firstly we want to address the changes of the size of the window, and so we can change the frame buffer which is held inside of the window where we will be rendering our scene. So then we are setting up the viewport, like the projection, like a kind of like a viewport, like the point on which we'll be watching the scene. And then we are like clearing everything what was drawn on the previous step, and we can actually draw something here. So there is nothing right there. And I would like to start with drawing some basic graphic axis coordinates. So to this, we need to draw something, we need to start with GL begin function, which apply an argument as something like the constant that will show what we actually want to draw. And we want to draw lines. This one. And to signal that we this will be end of drawing lines, we have to write this GL end function. And to draw the line, we need line drawn with 2 points. And to get a point, we have a function GL vertex 3, and so the x will be the first one, for example, -1, 0, 0, and the second one will be +1. Let's see what we have. So yeah, we just have one not very exciting line. And let me just copy some the code that I have prepared, so it will be much quicker. Yeah, and I'll explain it right now. So this one, it will be x coordinate, y axis, and z axis. And I'm using, I want to color them in different colors. So I'll use in this color library, which is like I wrote by myself. And this is basically just a library of preset colors. And all of them, they're using this GL color function. And it will be having an argument as a RGB channel coordinates. So we can apply this color to vertices that we want. We can color them. And let's see what we have. Yeah, so we don't see actually the third one because our viewport, like we are, like it's hidden right now. And it will be nice to actually see it. So we can rotate our scene to it. So we can actually have, so there is a function for it called rotate, and F, it's been like it accepts coordinates and float. So this function apply rotation transformation to every vertex that we have later. The first argument is angle, and I would like to use this GL FV get time function, which is like get time, and it'll be just changing over time, and we'll get this our rotation automatically. Let's see how it works. So yeah, so our viewport is rotating, and we can see the whole scene from different angles. So yeah, it's not very super exciting. We can continue, and right now on this step, let's draw some figures. And as I said, it's not very easy way to do it, because we can actually allow to draw not like with OpenGL, we can we are allowed to draw like very limited amount of shapes. And so let's see what params GLBegin accept. So we can see that it accepts. So like basically we are watching this constants. So we can draw points, lines, like different in different variations, triangles and quads, which is like squares, and it's basically very like they're easy to draw because it's just like two triangles in together. And if we want to draw something two-dimensional, we actually, there is no way how to do it. We have to create our own functions. So let's just do it. I've already, like, I've pre-created, and I'll want to draw right now a pyramid. And so pyramid will be drawing a pyramid, which will be containing will be drawn from the triangles and from equal triangles, and it will do the math like to getting the coordinates much easier for us. So basically, like there is a like the picture of the pyramids that I want to draw with Ruby, and we need actually it's quite easy because we need only 4 points to draw this figure. And basically, we need to know the x, y, and z for all the coordinates. And it's kind of like, for me, it was a bit, in the beginning, a bit frustrating, but then I realized that if we have like equal triangle, and we have this and inner sized circles, we actually need to know these radiuses of these circles to get any coordinates of these points of the pyramid if we have if this will be a center. So these radius are googled very quickly, so the formulas are very easy. And in this case, A is like a side of this triangle, and because it's an equal triangle, it will be like equal for every side of the pyramid. So let's just talk about this class, this draw pyramid. So we're accepting length of the side, the apex, like the high point So like basically, if we know the apex, so this means that we only need to figure out another 3 base points of this pyramid. And it accepts also colors that will be used for drawing, like coloring the vertices of our pyramid. And because we'll be using different colors for different, like we'll be coloring apex in different colors every time, so it will have nice shades and you'll just see it. So basically, this is the mat. Then we are drawing like we'll be drawing triangles, and in triangles we drawing all the points, and that's pretty. That's it. It's not very like a lot of code, but it's not very like easy to read because there is a lot of points here. So let's just draw this pyramid here. And I'll make it 0.5. And this is actually absolute coordinates. So we are having our viewport from our projection is from -1 to 1. So this means that we actually are not operating in pixel, we operating in some kind of absolute relative values. And we'll have, I want to right now that my pyramid will be just taking like half of the space of our viewport. The next one will be coordinate of the axis, and the color, and we have to pass some param. So I will use color and then arc. And let's try. So you can see it's blinking. It's blinking because on every step I'm using like a different random color, and that's why it's blinking. But yeah, we have something rendered here. And this is a point when we want to add some interaction. So we right now we just have like very simple animation, and basically it's something, but it will be much nicer if we allow user, because it's the application, and we can allow user to control the scene. And let's just start from like maybe giving the user to control on rotation the scene. So we basically need to so I want to when I press for longer the key, I want to the scene to be rotated. So we need to add a callback for some key which will be rotating the scene. Let me just copy it a few lines of code. Just skip this right now. And so what we want to do, so when we repeat, which means long pressing space key, we will be incrementing some value, and which will be an our angle for rotation transformation, and we just pass it here, and we can see that it's still blinking, but yeah, I am pressing space button and it's rotated right now. And let me just change it to something not blinking. For example, sorry. I'll need to use array. For example, 0, 1. So so we are rotating the scene, and it will be interesting to just like move this pyramid on the surface. So for this one, we need another different handlers. So we'll be controlling different keys that will be operating like on the go up, like go down, near, below, left, right. So we'll be controlling a transformation on a different axis. So if we're going in one direction, we'll be incrementing this transformation. If we're going in different one, we'll be like decreasing it. So let's just make them 0. And we need So so we have controllers, and we need to apply transformation. The transformation in OpenGL that will be changing, like moving the objects, moving the kind of moving vertices and objects in our case. It's called translate. And I want to apply it only to the pyramid itself. So we'll be rotating like the whole scene, but translate only pyramid. So like as I said, OpenGL operates on vertex matrix, and this basically this will be applied to the matrix that we have for this coordinates. Let's see how it works. So if I press, so like I'm pressing S, it should go down. Now it should go left, right, like just rotate it so you can see X, Z coordinate. Go, I don't know, near or like Z plus, Z minus is, I don't know the name for that coordinate. So yeah, it works. And the last thing that I want to show that we want to do with this scene, we can actually add more objects to the scene, and we can actually add another controller. So when we press some other command, let's say GL, if, for example, we didn't use it, no. So we'll be increasing the amount of objects in the scene. And let me just copy the last part of the code that I wanted to show. So I won't make any mistakes. Yeah, and so like what I'm doing, so when we press the P key, we'll be, so we have an array of our objects in our in the scene, and when we press key, we will be adding more objects. So I just replace the code here. So like if our like counter of our objects is different from the counter from the object that we have already in our array, we'll be pushing more objects from in different position. and of different color. And let's see how we see the scene. Yeah, and like when I press P, it creates more objects, and we can rotate the scene. And when I press the key that control translation, you can see that like it translates, and right now you can see that not everything is rendered. That's because my viewport is set for like these figures, they are outside of the viewport and we don't see them, and like OpenGL like remove them from the drawing. Yeah, and the last, like we have a few minutes, so I was kind of interested what we can do actually, how many objects that we can draw. Like I guess the safe number to show will be 3000. I've tried this for 10,000 and it was quite small, but I'm afraid that my laptop won't handle this stream, and then the scene with 10,000 objects. But also it worked with objects, but it was super slow. So let's see how it works with 2000. Yeah, so we have our pyramids. It's quite quick. It's rotating. It's nice. So if we'll have a scene with like, I don't know, 5,000 objects, it'll be much slower. And you can see it's slower than it was before. And if we translate, so it's removed from the scene and they're back. So this is all that I wanted to share with you today. So basically, this is very simple like script, and it requires like a little of dependencies, but it actually allows you to create something, and you can actually create your, like having this keyboard callback, you can create something interactive for your users. And that's nice, I guess. I guess it's really fun that on Ruby we can create something different from backend applications that we all love to do, but something different. And we actually on Ruby there is another like game engine called Gosu, but it's only for two-dimensional graphics. But if you want to try something for three-dimensional, unfortunately, if you want to create some like professional level animations and games, you have to, I guess, switch from the different language. But anyway, if you want to create something quite simple and fun, you can use Ruby, and I guess it's really big. I guess for me, it was really fun to dig into it, and I encourage you to try it because it's really fun. And I guess this is like, even if it's like this code right now, it's super ugly because it's written in hurry, and it's just like one giant loop and one giant script. But anyway, this is, I don't know, this is the most beautiful code that I've written in all my life. So thank you for listening to me. And right now, I guess we'll skip to Q&A.
Thank you, Tetiana. That was wonderful. I love looking at these kind of talks take shape. Sorry, I promise I wouldn't do any puns. Listen, it's been absolutely wonderful to see you live code. Massive props. It's what a great talk. Let's give you a moment to have a sip of water. Folks, start writing those questions into the YouTube chat. We want to hear from you. In the meantime, let's check on our developer dilemma. So the question was, should developers do design or should designers do development? So you've all spoken, and the results are 20% of you think that developers should be doing design, and 80% of you, that is 80% of you, think that designers should be doing development. Well, let's jump into some questions. Raita, would you like to start?
Yeah, so Tetiana, one of the questions is that what made you want to try OpenGL?
So basically, I wanted to try to draw something, and basically we don't have any options like to do it easily, because maybe I will forget to mention this during the talk. OpenGL is a cross-language and cross-platform APIs that use like basically on every device. And right now, like there is no alternative for it right now. Maybe in the future it will be replaced by Vulkan, but like it is just the basic place, the right place to start. There is another graphic engines and libraries to draw graphics, but I really wanted to like dig into like the most low level and understand how it actually works under the hood. And when you like because it's everything like, you know, OpenGL, you works with vertex and with matrices, and you works with matrix operation. It's like, it's really different. Like it's not, at this point, it's not graphics, it's like math. And it's, for me, it was really fun to dig into it.
Thank you.
Thank you. Thank you. Yeah, that's super cool. I'm curious. This is a question from me. I'm just gonna take the opportunity. Did you also, or can you with Ruby, have you looked into WebGL as well?
I actually didn't try WebGL with Ruby, but because actually kind of I have like some experience with OpenGL in past, because I was trying to write some program like games with C# and their game engines that they have. So for me, it was much easier to start with OpenGL. But I know it's like it's really using the same techniques as OpenGL. So yeah.
Awesome. Thank you.
Thank you, Tetiana. So for the questions, I'm gonna look at our tech guy if we're ready to get Penelope in for our panel.